So we're going to look at each of these separately. We'll look at this first one, then we'll take a little break and we'll go on. So a mass-mass problem, we have an unknown mass, and we're calculating that from a given mass. So the path. In unit analysis, we talked about a path. Like Dora asks the map where to go, and he tells her, you know, you have to go over the bridge and then through the scary forest, and then you get to the snowy mountains, right? And we have this idea of where we're going, and then that leads us through these unit analysis problems that we have to do to get through the class, right? So for a mass problem, you're going to start with grams, and we're always going to have to go to moles in the middle, because we don't know what the relationship between the grams of product and grams of reactant is, but we know from the chemical equation the ratio of moles. And so grams to moles to moles to grams. This is the stoichiometry chant. Grams to moles to moles to grams. And you know you're getting it when you wake up in the middle of the night muttering grams to moles to moles to grams. The other problems are just a variation on this. So if we say that the given mass is for compound A and the wanted mass is for compound B, then it would be grams of A to moles of A to moles of B to grams of B. Each of these arrows, it needs a unit factor. The unit factors for this sort of a problem, you're going to have the molar masses of each substance. So going from grams of A to moles of A, you're going to need the molar mass. And at the end, going from moles of B to grams of B, you need the molar mass. And the one in the middle is the mole ratio from the balanced chemical equation that we just learned about. So this is the big idea of mass-mass problems. Let's do one. What mass of aluminum is needed to convert 63.5 grams of iron 2 oxide to elemental iron? So it says right up here, mass-mass problem, right? But let's look at this. What mass to convert this many grams? I think it's helpful. We're always going to have a balanced chemical equation. I think it's helpful to use the balanced chemical equation to help us organize these numbers, because that's one of the big stumbling blocks for a lot of people is, here are all these words with a couple numbers. How do I translate this into an equation and get an answer out of it? So the question, what mass of aluminum? Well, find aluminum in here. It's Al. So I'm going to write question mark grams, because gram is a unit of mass. Needed to convert 63.5 grams of iron 2 oxide. So this is the iron 2 oxide, and I'm going to write its mass underneath. So my path for this is going to be grams of the given thing. I'm going to have to convert that to moles of FeO. And then I'm wanting aluminum. So I'm going to convert that to moles of aluminum and then to grams of aluminum. Grams to moles to moles to grams. What you're starting with to what you want to end up with. This is the path for our equation. It's going to have 3 terms in it, 3 unit factors. Most of these types of problems will have 3 unit factors. So I'm just going to start over here, 63.5 grams of FeO, 3 unit factors. Grams FeO to moles FeO to moles aluminum to grams aluminum. Those are the units that go in the numerator. Mole FeO, mole aluminum, grams aluminum. Same pattern we learned. And then I take this unit, grams of FeO, and that becomes the denominator here, so those units cancel out. All of this is unit analysis. Grams, FeO. So that cancels. And then here I've got moles, FeO, and that cancels. And then down here I've got moles of aluminum, and that cancels with this guy over here. Units first. Put the units in first, because they tell you what to do with the numbers. And so it takes a lot of the thinking and puzzling out. Units first, then the numbers. So now I'm going to put the numbers in. Personally, I like to start in the middle because this one's easy. The mole ratio, we just have to look at the equation and pull down the coefficients, right? In front of FeO is the number 3. So in the mole ratio, that's going to be a 3. In front of aluminum is a 2. So in the mole ratio, I'm going to write a 2 for the aluminum. 1 down. The first one and the last one are molar masses. The last one's easier because that's an element. 26.98. Straight off the periodic table. 26.98 grams of aluminum is equal to 1 mole of aluminum. For FeO, we're going to have to calculate that. I really encourage you to write down your calculations for molar masses, because then if you make an error, you can go back and find it, and you don't have to do the whole problem over again. So iron is 55.85. Oxygen is 16. And I don't trust my brain calculator anymore. 71.85. When we do that calculation, we come up with the number of grams that are equal to 1 mole of that substance. So 71.85 grams goes in the denominator. Any questions? Now I start from the left like I'm reading, and I go straight across, multiply by the top, divide by the bottom. 63.5, you multiply by 1 if you want to, divide by 71.85, times 2, divided by 3, times 26.98, equals. This is my final answer, and so I'm going to, thank you, I'm going to round to the correct number of significant figures. How many sig figs should I have? 3. This mass that I was given here has 3. This one's 4, this is exact, that one's 4. You don't want your unit factors to be limiting the number of significant figures. You'd like this to be limiting. So 15.896 is going to round to 15.9 grams of aluminum. When you write all these units in here, mole is not good enough. You have to have moles of what? Because we have moles of aluminum and moles of iron oxide, and we need to keep them straight. Grams isn't good enough either because we have grams of different things. Okay? Any questions? Let's do this example. Calculate the mass of carbon dioxide released from 10 grams of cobalt-3 carbonate given the unbalanced equation for the reaction. So we're going to practice our equation balancing. Let's look at this. I'm looking at the cobalts. There's 2 on each side. Those are okay. There's oxygen everywhere, so I'm going to ignore him for a while. Look at the carbon next. How many carbons in this one? 3. And how many over here? 1. So if I put a 3 there, I've got the carbons straightened out. That should take care of the oxygens, but we have to check. How many oxygens over here? 9. And how many here? 3 and 6 is 9. Okay, so we're good. Cobalt-3 carbonate, 10 grams. So I'm going to write 10.0 grams down here. It says calculate the mass of carbon dioxide, question mark, grams. That helps me to identify what I'm starting with and what I'm trying to find out. I've got a mass here and a mass here. This is a mass problem. I've got the number for this one, so my path will be, and yes, it's tedious to write these formulas, CO2, CO33, grams of that, 2 moles of the same thing, to moles of the other thing, carbon dioxide, 2 grams of carbon dioxide. Grams to moles to moles to grams. That's my map, my strategy, my plan, and so now I'm going to work the plan. 10 grams of CO2, CO33, times, here I'm going to have moles of the cobalt carbonate, crazy long formula guy. And then 2 moles of CO2, 2 grams of CO2. Grams to moles to moles to grams. Previous unit comes down. Previous unit comes down. I frequently have students tell me that it looks really easy when I do it. And then they go home and they try to do it and they're like, oh, wait a minute. You know, it's like watching Michael Jordan slam dunk a basketball or something, right? He makes it look easy. I can't do that. I can't. This isn't based on physical ability, though. This is based on using your brain. And so it looks easy, and it is easy for me because I've been doing this for years, right? But if you follow the steps and practice, it can become easy for you, but it does require practice. Do not be deceived into thinking, oh, well, that looks easy, I'll remember how to do that, without practicing, because that's a recipe for failing an exam. Okay, cobalt. Where'd you go? There you are. Focus. 58.93. Is that right? I really need to bring my own periodic table. 2 times 58.93, or maybe some binoculars or something. 2 cobalts, 3 carbons, 12.01, and 9 oxygens. Some of these numbers look kind of big. It's okay. Sometimes they are kind of big. 2 times 58.93 plus 3 times 12.01 plus 9 times 16, 297.89. That's a big molar mass. So 1 mole of that cobalt carbonate weighs 297.89 grams. The mole ratio is going to be what? What goes with the CO2? 3. And what goes with the cobalt carbonate? 1. And then we need the molar mass of carbon dioxide. Mass of carbon plus 2 times the mass of oxygen comes out to 44. 10 divided by 297.89 times 3 times 44.01. This is going to equal 4.43 grams of CO2. My starting number of 10 had 3 sig figs. My result is going to have 3 sig figs. Good to practice your sig figs and look at it, but if sig figs gave you a lot of trouble, a good shortcut here is however many you started with, that's how many you should end up with. Works most of the time. Any questions? I don't think we need another example of that one. we'll skip that.